Hi everyone, welcome back to my channel Learnatcloudanalytics. So today we are going to talk about logical functions in Power BI DAX. So among the different logical functions that we are going to discuss, these are some of the important functions that we have here in Power BI. So today we are going to talk about what is true function, false, if, nested if, switch, coalesce, if error, and some logical operations as well, like and, or, and negator operator, which is not operator. So let's get started. So let me first go back to my data set. So I've already connected to the Superstore orders data, as you can see here on my right side of the screen. So what we are going to talk about is first let's understand what are these logical functions. So the logical functions are mainly used to perform the conditional evaluations in Power BI. So when I say conditional evaluation, what does it mean? So conditional evaluations is nothing but comparing each and every value with respect to some condition. So let's say that I would like to compare category values with respect to my sales value, saying like for which category do I hold the highest sales amount, or for which category do I have the lowest sales based on some criteria. So the highest and the lowest, I can specify a condition saying which are the categories that are holding the sales above 1 million, or maybe in the range of 1 million and 3 million sales, right? So these are termed as the conditional evaluation, or comparing the sales value, or comparing these values with respect to certain condition. So the condition here is implying to like let's say the sales value which is above 1 lakh, or maybe in the range of 1 lakh to 3 million records, right? So these are some conditions. Now, how can we perform these conditional evaluation in Power BI? So in Power BI specifically, we can perform the conditional evaluation in two ways. So what are those two ways? So we can perform the conditional evaluation in two ways. So let me make a note of it. So the two ways of performing the conditional evaluation is nothing but the single conditional evaluation and multi-conditional, or multi-conditional evaluation. So I'll say single condition evaluation or multi-condition evaluation. So within these two ways of performing the conditional evaluation, let's understand which are those functions that we've seen earlier would fall into either of them, right? So not every time we would be required to compare the values with respect to a single condition, right? So there could be certain situations where we might arrive at a state that we would need to compare with multiple conditions, like in the previous example which I said, like where if I wanted to analyze my categories whose sales are in the range of, let's say, 1 million and 3 million sales. So that is a multi conditional statement because I have a condition saying within the range of 1 million and 3 million, and also I could say maybe um, about 3 million. So these have been classified against the multi conditional evaluation. So let us further go ahead and understand how these can be uh, applied against the different tax functions that we have in Power BI. And before that, first let's understand which are those functions that have been categorized as a single conditional functions that we can use, and which are those functions that we could apply when we have a multi-conditional evaluation. So for the single conditional evaluations, we could use the if conditions, like the if functions, and within the multi-conditional evaluation, we could use the nested if and also the switch functions. Okay, so we can use the if condition or the if function when we have a single condition, but when we have multi conditions to be evaluated together, we could either go with a switch function or with a nested if functions. So let's see and understand how we can use these functions first. So let me go to a new text box. All right. So what I would like to help you understand is, um, okay, let's first understand what are these conditional evaluations again. So you might think about, okay, I just mentioned that conditional evaluations are nothing but comparing each and every value with respect to a certain condition, right? Now, what are we trying to achieve with these particular conditions? So what are we going to achieve when we apply those conditions? What exactly are we trying to achieve in there? So when we, or with respect to the, or with the help of the conditional evaluation, we are going to create KPIs. What are we going to create? We are going to create KPIs. So KPI stands for key performance indicators or key progress indicators, and these are nothing but the strategic goals of an organization. So every organization would try to create some KPIs which would help them to set some strategic goals for that company to progress ahead, right? So using these conditional evaluations or using these logical functions that we are going to discuss now would help the companies to set or define KPIs that would help their company to progress. Okay, so that is the main purpose of using these conditional evaluation functions. So now that we've understood thoroughly about what are the logical functions with respect to the theoretical part, and what exactly are we trying to achieve by using these logical functions, that is nothing but the KPIs which would help the organizations to help them progress ahead. So now let's go ahead and discuss one by one functions, like every function that we have within the logical functions in DAX Power BI. So with that said, let me go ahead to a new page. And as I've already connected to the data set, which is the Superstore orders table. So first I would like to create, okay, so let's evaluate the first function, which is the true function. So true function is always helping us to return the output as true. So let's understand this again. So I will make a note of it just for your reference. So the first function that we are going to talk about is nothing but the true function. So the true function helps us to return the output as true. So the syntax of this function is nothing but just true. Okay, so let's go ahead and apply this function. So for that, I'm going to create a new column and I'll just name this as true, and I'll use a function true function, and I'll just hit on apply. So the moment I hit on apply, it just returns the output value as true. Similarly, we have the other function, the second function in the logical functions, which is false function. So false, similar to that of true, it would help us to return the output as false. Okay, so I'm creating another column called false, and I'll give this function as false function, and the output would be returned as false. Okay, so then we'll go ahead with the third function, which is the negation operator. The third function is the negation operator. So what is the negation operator here? Not is the negation operator that we have in the logical functions. So not, so when I say not, and if I say not true, for instance, okay, so not true gives or returns the output which is the negation, which is the opposite of that particular value. So not true means, so true function would always return the output as true, and when we apply not in front of this function, now this would become the opposite to it, which is the false value. So now when I hit on apply, I would be seeing the output resulted as false. Okay, so that's the negation operator. Now let's go ahead with the fourth function, which is the important one. So the fourth function that we are going to talk about is the if function. So for that, let me go ahead to the orders table. So what I'll try to do here is by using the if. So we understood. Okay, let me first write the syntax of the if function, and then we will understand how we can apply this. So the syntax of if is if condition, comma, then statement, and then followed by the else statement. So what it meant is whenever we have a condition being uh, which needs to be evaluated, right? So if that particular condition is true, then we get the output returned based on the then value. If the condition is false or if the condition is not met, then it would consider the else part of the statement and return that as the output value. Okay, so that is the syntax of the if function in Power BI. Now let us try to do a small task and understand how this if function can be applied on my data set here. So for that, I would like to consider a small example like maybe I'll just take this category. Okay, so within my category, I have three values here, and okay, and then I would like to evaluate a condition that uh, what are my sales which are above or less than a certain value. So before that, let me apply or bring in my total sales value. So here you can see that my total sales value is shown as sum of sales here, and these are nothing but termed as this. So this sum of sales measure is nothing but the implicit measure. So implicit measure is nothing but the value or the aggregation that comes directly from the data source itself. So we are not trying to apply any aggregation here, but by default it has this aggregation of uh, let me show you that. So I'll come back here. So if you see, it is by default considering the aggregation as sum, and you can choose among these any one of them if you need to change the aggregation type. But if this value is if the aggregation is directly applied at the visual level, then it is called as the implicit measure. It is called as a implicit measure. In case if you would like to understand a little bit deeper on what is an implicit measure, I did create a video already on implicit and explicit measures. So I will leave the link in the description below so that you can just go back and revisit that video for your better understanding. All right. Now, for our comparison or for our conditional evaluation, it is always recommended that we create the explicit measures because as part of your DAX calculations, it would be it is suggested that we have the calculations, the aggregation fields being created separately so that these measures can be reused among our different calculations that we create. So for that, I'll create a new measure. So I'll come back to my table and say new measure, and I would call this as total sales. And what is my total sales of calculation? Sum of sales from my orders table. That's it. So I'll hit on apply, and I will be listed with the new measure value that has been created as total sales. So I'll bring in that total sales value onto my visual. Okay, so you can see that both the values are displaying the same result, but the difference is that this total sales measure that we just created is or could be reused in different functions as needed, and this is our explicit measure, and this is called as a explicit measure. Okay, so let me remove this previous measure that we've added up, and now what I would like to do here is I would like to evaluate this values, the total sales values against my category. So let me create a new measure here, and I'll say, so let me say sales condition. Okay, and what formula do we apply here? If total sales is greater than, if total sales is greater than 6 million, okay, or 6 lakh. So I'll say if total sales is greater than or 7 lakh, then good, else bad. Okay, so now let me hit on apply and bring in this KPI onto my visual. And if you observe here, since all these values are above 7 lakh, it is displaying the output KPI as good itself. Let me make a modification to it. Let me say that if it is above 7.5 lakh. Now let's see. So now I have the office supplies KPI value being displayed as bad because that is not meeting to my condition. So this is my condition. So what is my condition? The condition says total sales is greater than 7,50,000. If this condition is true, then it will display this then part of the statement. If this condition is false, then it will consider the else part of the if statement. So that is how the output is being displayed currently on this particular visual. Okay, so I hope you understood the if condition here, like how to use the single if condition when we need to apply against comparing the different values. All right, now let me go ahead and try to do a little bit of multi-conditional statements. Okay, so till now we are just focusing on a single condition. Now what if I have to compare or evaluate multi-conditional statements, right? So again, how do we do that? So let me try to create another measure here. So I'll create a new measure. Now what do I like to do? So I will call this as sales condition 2. Okay, and the formula that we'd like to use here is if total sales is less than 7.5 lakh. Okay, if it is below 7.5 lakh, then we'll say it is bad, or maybe first we'll say if it is above, okay, greater than. If it is above, we'll say good. And let me go to the next line item. So, how do I go to the next line? By pressing Alt and Enter. Okay, when you hit Alt and Enter, we would be resulted on the next line. Okay, so here again I have to use another if condition. So this is a nested if. So if, what is my condition here again? Total sales is less than 7 7 lakh. Okay, then it is bad, and the else part of this condition is okay. So for the else part, you need not write that condition again or that then statement again. So you can just put the value directly. Now let me hit on apply, and this is my sales condition 2. So let me bring in that sales condition 2 along with this sales condition 1. Okay. So if you notice here, we have the output value as good and okay, but we don't have the bad. So why did we not have this bad value being displayed in my output? Because for the bad, the condition that we have mentioned is if the sales value is less than 7 lakh, but we don't have any sales value which is below 7 lakh, and therefore we didn't see that particular value being displayed against my category. Understood? So this is about how you can use the nested if conditions when you have to evaluate multiple conditions. So I'll repeat this formula again for your understanding. So here, since I wanted to evaluate multiple conditions, here I would like to evaluate if my total sales value is greater than 7,50,000, then it should be displayed as good. And if my total sales value is less than 7 lakh, and it should be displayed as bad. But if it is in between 7 lakh and 7 lakh 50,000, then it should display as okay. Okay. So this is how we can write a nested if condition as per a requirement. Now the same formula, if I'd like to use within a switch function, how can I write this? So let us try to create another formula here. Okay, so again I will create a new measure. Now how do I write this formula? So first let's understand how the switch function would work and what is the syntax to it before we even write this formula. So the formula for the switch is, so the formula or the syntax for the if condition switch formula is, switch function is, so switch syntax is, the syntax of switch is switch of expression, comma, value 1, comma, value 2, sorry, result 1, comma, value 2, comma, result 2, and so on. So it could evaluate n conditions, or it can evaluate n conditions. So let me explain the syntax to you in detail. So here we are saying within the switch function, the first value that we are going to parse is the expression. So if this expression is matching with the value 1, then it gives us the result 1. Or if the expression is matching with value 2, so let's say that if my expression is not matching with my value 1, then it will go to the next line item which is my value 2. So it will verify if this expression is matching with value 2, then it would result with result 2. If this is also not matching, then it will go and evaluate the value 2, value 3 value, and see if that is matching. If value 3 is matching with expression, then it would result with result 3 value. So likewise, it would try to compare and match the values that are meeting, and accordingly it would display the output result. Okay, so that is the syntax of a switch function. Now let's try to create a formula, like let's try to evaluate on the same example that we have seen above and see how we can write this logic in here. So again I will create a new measure. Okay, and so now, okay, so now, sorry, yeah, okay. So now what I'll try to do is I would try to get my, let me create this new measure. Okay, so I'll say new measure and I'll say paste and say condition 3. Okay, so this we would like to write in using the switch function, right? So switch, and how do we write this expression? So what is the expression? So here in the expression, okay, let me say that, uh, let's try to give this as it is. Okay, so I'll say switch of total sales greater than 7,50,000 as good, or if total sales is less than 7 lakh as bad, else okay. So if I give this formula like this, it would return as, okay, so that would be resulted as, let me show you. So here let me bring in that new measure that we've created, which is sales condition 3. So see, when I bring in that formula being applied on my visual, right, it is throwing me an error. It says can't display the visual. So let me see the error message, why it is throwing that error. So when I hit on see details, it says the calculation error in measure sales condition 3. Functions which does not support comparing values of type true or false with values of type text. Consider using the value or format function to convert one of the values. So this is most commonly seen error when we work in a real time situation. Now how can I fix this particular error message? So let me go back to that formula again and show you what exactly is happening. So when I say, when you remember the syntax to it, right? So the syntax says that within my switch function, first we have to specify the expression, and then this expression would verify, or it will try to compare with my value 1. If both of them are matching, then it would result with the result 1. Else it would then go to the value 2 and verify if expression is equal to or if it is matching with value 2. If both of them are matching, then it would output the result as result 2. Right? So this was the syntax of using the switch expression. Now, what we have done in our formula is that we haven't specified, because this is a measure, right? This is an aggregated value. It is not able to give the exact output as needed. So, what I'm trying to say here is, because that I wanted to compare the measures values, if that expression is true or not, I should first give that expression which is meeting that criteria, right? So therefore I would like I would need to use the I would need to use the function true. And now when I say the total sales value, if it is above, and so when I say switch of true function, so what does the true function return? True will always give us the true value in the output, right? And this is my expression, right? So this is my value 1. So what is it doing? So the value 1 is a condition. So here in the condition, it can then validate if the total sales is greater than 7,50,000. Then if this is true, If this expression and value is true, then it will result with the result 1. If this is false, like let's say if this condition is not, like this particular value is not meeting with the or matching with my expression true, then it will go and evaluate with my other value. So this is my total sales less than 7 lakh, and then it will result with the result 2 value, else it will result as okay. Got it? So this is how we are supposed to use the switch function when we have to evaluate a multi-conditional statement. So let me apply it. Okay, and come back to this visual. So now you can see that the visual has been corrected and we are seeing some data being displayed as expected, right? So as you can see here, both my condition 2 and condition 3 are giving me the same results. So the condition 2 is based on my if nested if statements, while my condition 3 is based out of my switch function. Now let's understand, when do we need to use the if, the nested if condition, and the switch function, right? So before that, let's try to do another small example of the switch function, and then we will come back to this comparison and understand when do we need to apply which and which one is more performant than the other one. Okay, so I will go to a fresh page, and what I'd like to do here is, so let's say that I'm just taking my order date. So in my order date I have the values as date values, right? Now let's say that I would like to get the quarter values out of it. So how do I get the quarter values? So I will create a new formula as quarter. So we have the function called quarter which would extract the value. So what I'd like to do is I will create two columns. Okay, so I will create a column, a new column, and I'll call this as quarter. And what am I trying to do? I'm trying to extract the quarter from my order date. Okay. So when I hit on apply, and let me bring in this quarter. So since this quarter value is based off of a numerical value, by default it is taking or applying the aggregation as sum. So in case if we don't want to apply any aggregation, we can just come back, we can just select that field and come to this option to select don't summarize. Okay, so then it will just show up only the values being displayed here. So I can just remove the sum of quarter to um, okay. So now let me remove it again and I'll add it up. Okay, so now I can see the values being displayed as numerical values instead of the aggregated values, right? So this is how we expected to see in the output. So here, instead of seeing the quarter values as 1, 2, 3, and 4, I would like to see them being displayed as Q1, Q2, Q3, and Q4 for my better understanding. Okay, so since I wanted to display the quarter values from 1 to 3, 4 to Q1, Q2, Q3, and Q4, how can we do this? So let's try to create new formulas by using both if and the switch functions and try to evaluate both of them again. So firstly, let me try to create this by using a switch function. So again, I'll go to my orders table. I'll create a new column. Okay, and I will call this as quarter 1, and I'll use the switch function, switch off, and what are we trying to do here? Switch off quarter on top of my quarter field. If this expression is meeting 1, then I would like to display that value as Q1, right? And if that expression is resulting value as 2, then I would like to display that as Q2. Similarly, if it is 3, then it should be displayed as Q3. Else, it should be displayed as Q4. Okay, so let me explain this formula again. So this is my expression, which is my quarter. Now the value 1 is 1. So when this expression is meeting 1, then I would like to display that value as Q1, which is my result 1. If my quarter value is equal to 2, then I would like to display that value as Q2. If my quarter value is equal to 3, then I would like to result that or display that value as Q3 instead of 3. Similarly, if that quarter value is 4, then I'd like to display that value as Q4. Now let me try to apply this, and now let me try to bring in that value against to my visual here. So Q1. So as you can see here, we are now able to see the quarter values being displayed as required. Got it? Now let me try to write the same formula using the if statement. So how do we write using the if statement? So I'm trying to create another column and I'll call this as Q2. Now instead of switch, I'd like to use if. Now remember the syntax of if. So for the if, we need to have condition 1 comma then, and again if condition 2 comma then. So this is for the nested if condition, right? So here again, how do we write it? If quarter is equal to 1, then Q1. Again, if quarter is equal to 2, right, then Q2. And again, if quarter is equal to Q3, 3, then it should be displayed as Q3. Else Q4, right? So this is how we can write a nested if condition. So this is a nested if conditional statement. Now when I bring in this Q2 quarter 2 value here, it would display the same results being populated. Okay, so now let's try to understand which function is more performance oriented than the other one. Now we have seen two ways of writing this switch and the nested if condition. One is with when comparing the measure values, and the other one is for the uh, dimension values, right? So when do we use a column and a measure? Did you not get that question in your mind? So let me explain this again. So when you have to deal with measures, or when you have to deal with aggregated values like sum, min, max, average, or any aggregated function being applied or a numerical value, then we have to create a measure instead of a column. Okay, and when do we use a column? Columns are used when you have to deal with the dimensional values. Okay, so here in this case, since we are just dealing with the uh, dimension value, which is my order date, I'm not doing a sum of or min of or any such aggregations being applied on this order date. Rather, I'm just trying to provide or evaluate that condition with respect to my value, right? So therefore we have created a column here. So here, uh, if I evaluate both my formulas, so switch, so let me try to create and this my Q2 nested if, So here, okay. So now I just wanted to show you the comparison between these two functions just for your better understanding. Okay, so this is the formula that we've used for both switch and the nested if statements, right? Now, if you carefully observe here, for the if statement, we are trying to uh, write or define the condition multiple times based on the values that are there in that, or based on the conditions that we would like to evaluate. We have to write those many if statements, right? Whereas in the switch, we can just parse the expression once, and then we can just compare the values with respect to the results as needed. So here, when compared to the if nested if expression is matching with value 1, and it gives the result 1. Likewise, it compares with n values, right? So here, if rather than if condition, switch function is much more performant because here it is trying to evaluate the expression only once. Whereas in the if nested if condition, it has to compare every condition individually row wise. So therefore, this is switch is more performant when compared to the nested if when it is related to the uh, dimension value comparison. Whereas when it comes to the measure values, right? Like for the measure comparisons, here, if you notice the measure values or the measure comparisons, right? In the measure comparison, uh, unlike the switch and the nested if that we've seen in the dimension comparison, here the if is comparatively performance oriented than the switch condition. Why? Because here the switch has an additional function which is the true function. So since it has an additional function, it would need to fetch the results according to that value as well. So there is an additional step along with the existing conditional evaluation. Therefore, here when it comes to the measure comparisons, switch function is little less performant oriented than compared to the nested if statement. Okay, so these are some important tips that I would like to share with you to remember when you usually deal with such kind of a criteria. Okay, so now that we've understood the if, nested if, and the switch functions, let's go ahead and understand the next important function that we are going to talk about is the end function. So the next function is the end function. So what is this end function? So the end function is nothing but it's the logical end. So when you'd like to compare multiple conditions together or a single condition, you can use the end function. So the syntax of this end function is end of condition 1 comma condition 2. Okay, so if both these conditions are met, if both the conditions are true, then the output is resulted as true. If one of them is true, even if one of them is true, the other one is false, then the output is always resulted as false. Okay, so this can be represented even by using the logical AND operator, which is the ampersand, double ampersand. So this can also be used instead of using the AND function. The other function that is similar to this is the OR function. So again for the OR function it's the same syntax, OR of condition 1 comma condition 2, and this can also be represented by double pipe. Okay, so these are some simple denotions or the simple representation of logical and logical or functions in Power BI. Now let's try to do a small example and understand how these functions can be applied in a real time scenario. So let's say that in my data set, okay, I'll just go back to my calendar table. Okay, so let's say that in my calendar table, as you can see, the date column has the list of dates being represented as day wise data, right? Now, let us try to find the weekday and the weekend. Okay, so let us try to find the weekday and the weekend value. So which means that we'd like to find the day type in that particular column. So how do we identify if that is a weekday or a weekend? So we have a weekday function in DAX. So we can use that weekday function to extract what is the weekday of that particular date column. So let's try to first evaluate the weekday. So I've just created a new column, and let me write the formula here. So I'll just call this as a weekday and weekday of date. Okay. Now when I hit on apply, you could see that the weekdays have been categorized or represented as 1 to 7 values. So 1 being Sunday and 7 being Saturday. Okay, so since I haven't mentioned the weekdays, the default weekday is 1, which is Sunday. So the week starts from Sunday and it ends on Saturday. So that is the default weekdays calculation. Right, now since now that we have got the weekday calculation created, let us try to evaluate the day type, whether the day is falling on a weekday or if it is falling on a weekend. So how do we evaluate it? Again, let me create a new column, and I would call this column as day type. Okay, so here in the day type I will use the if function. If my weekday is 1, or my weekday is 7, which is my Saturday, then it is a weekend, right? So if my weekday is 1 or 7 means Sunday or Saturday, that is my weekend, right? Else it is a weekday. That's it, right? So let me apply this, and now you can see that we have the weekday and weekend being categorized. So let me select weekend, and you should see all the values as 1 and 7, because 1 is nothing but the Sunday and 7 is falling on Saturday. So both of them we have treated them as weekend, so therefore it is displaying as weekend. And if I select weekday, weekdays are from 2 to 5, right? So you can see all the days that are in the weekday duration. Now the same formula we can rewrite by using the or function. So here simply I've used the double pipe notation to add the logical or condition to evaluate this particular expression. So instead of writing this, you can also use the logical or operator. So let me create that new column. So I'm just selecting everything. Okay. So I just copy this formula again and create a new column, and I'll say day type 2. And here, how do I write the or function? So the syntax of or is or of condition 1 comma condition 2. So here again, if or of, what is my condition 1? Weekday is equals to 1, and the second one is weekday equals to 7. Then it should be weekend else weekday, right? Okay, now let me hit on apply. Now we got the same results being displayed. So this is how you can use either the logical or function directly like this being applied. So the syntax is or of condition 1 comma condition 2. So here the condition 1 is if the weekday is 1 and second one is weekday is 7. So these are my two conditions. So I just written my I just wrote my first condition here and the second condition here, close the parenthesis, comma. If this condition is true, then we say the true value as weekend. If the condition is not true, then the else part is weekday. Okay, and these I have written within my if condition so that I can validate or do the comparison. Okay, so this is how we can use or write the logical or operator. Similarly, we can write the logical AND operator also using that AND function. So these are the different functions that we have in the logical functions type. So lastly, we are left with the two important functions which we usually use in real time as well, and it's also important for your interview point of view. So let me say, let me go back to my orders table. Okay. So the next function that we need to discuss is the if error. So the next function is the if error. So the if error function helps us to evaluate if the first expression 1 is giving an error, then it should be returning the second expression value, right? If not, it would return the expression 1 value result as it is. So the syntax to this function is if error of expression 1 comma expression 2. So like I did explain, it would try to evaluate if the first expression 1 is giving an error, then it would return the output value as expression 2. So let's say that, let me go to the, okay, so here I'll create a new column and say 25 by 0. So what is 25 by 0? So 25 by 0 would result in infinity, right? So because we can't divide, so we can't divide any value with 0 in the denominator, therefore it is returning as infinity. So since it is not a valid value, we would like to get or mention or replace that infinity value with a proper value so that we understand that there is a error value that is coming up in my end result. So for that we can apply this if error function. This is my value 25 by 0, and if this value is returning an error, then I would like to output the value as -1. Now when I hit on apply, you should see that the value results in -1 in the output instead of the error value. Okay, so this is an important function. So whenever we have an error coming up from the expression 1, we can denote or represent that value with a different value by specifying in the expression 2 value. So that is the if error function in Power BI. The last function among the logical functions is the coalesce. So what is a coalesce? So the coalesce would try to return the first non-blank value. Okay, let me show you with an example. The coalesce and what, so the syntax of coalesce is value 1 comma value 2 comma value 3 and so on till n value. So let me say that I have some list of values like blank, blank, and then maybe 2 comma blank and comma 10 comma 20, something like this. So in this given list of values, it will try to verify which is my first non-blank value. So in the first value I have a blank value, and in the second value I also have another blank value, wherein the third value is my first non-blank value, which is my 2. So that would be resulted as my output when I use this coalesce function on top of these list of values. So as you can see here, it is returning the first non-blank value within the given list of values. So that is all about the different logical functions that we have in Power BI. So I hope you are able to understand thoroughly the different logical functions that we have in Power BI DAX. So if you do have any questions, please do leave a comment in the comment section. And also if you'd like to understand a little bit deeper about any one of these functions, please also leave a comment in the comment section. So I hope you all have a great day ahead and thank you for watching my video.